So I'm hoping that this is the last lecture in stoichiometry. So previously we have talked about stoichiometry, limiting reactant problems, and now we actually are going to be talking about the percent yield problems. So percent yield problems is a little bit more realistic in this case. It's actually telling you how good the process is in creating a product. One note of this is whatever you do, if you do the math that's initially shown to you up on top here, you cannot exceed 100%, right? In fact, if you are very, very close to 100%, there is something wrong with your calculation, all right? So that is very, very important here. So here's an example here. So the way that you know it's a percent yield problem is obviously I'm going to ask, what is the percent yield? The other thing is it tells you already how much product was created, okay? So there's going to be two units given to you, similar to like a limiting reactant problem, but the difference between percent yield and limiting reactant problem is in the limiting reactant, the two numbers that's given to you are both reactants. In a percent yield problem, one of the numbers given to you is going to be a reactant. Hydrogen is a reactant, obviously, and one of the numbers given to you is going to be a product. So water is obviously a product, right? So what do you do with this number? The first thing you do with a percent yield problem is you will ignore the product first. And what you're going to do is you're going to just perform a gram to gram problem, gram to gram problem, where you start with grams of hydrogen and you're going to calculate the theoretical yield of water. So you're again ignoring this grams of water for now. So if you go from grams of hydrogen 2 grams of water using this balanced chemical reaction or using this table and this balanced chemical reaction, what happens is this is the setup. So 10 grams of water of hydrogen, starting here, 2 moles of hydrogen. 1 mole of hydrogen is 2.014 grams of hydrogen. Then you use the balance equation. Again, anytime you use stoichiometry, you always use the balance equation once. 2 over 2, because there's 2 hydrogens to 2 waters. And then you go from moles of water to moles, 2 grams of water, and obviously the molar mass of water is on top, the 1 mole is on the bottom. And if we use 10 grams of hydrogen, theoretically we should get 89.4 grams of water. This is 100% yield. However, what we actually got is 29.78 grams of water. So this is when you go back and remember this number, and now you're going to compare these two numbers. So this is the theoretical yield. Theoretical yield is always a product of a gram to gram problem, okay? The grams that's given to you is always the actual yield. And so if we do this math, which is actual yield divided by the theoretical yield times 100, this is the actual yield divided by this theoretical yield times 100, we get a 33.3%. So this process that was done initially is 33.3% efficient, if you want to think about this way. Again, this number is good because if you get a number like 98, 99%, 100%, 120%, this should send off alarm bells in your head that is actually an incorrect number. So again, difference between percent yield and limiting reactant yield. In limiting reactant, the 2 grams given to you are both reactants. In percent yield, one of them is a product, the other one is a reactant. Okay, so in here again, we see that we work from grams of H2 to the theoretical grams of water, and we found out that the amount of water that was 100% produced from 10 grams of hydrogen is actually this. Then we compare what we actually got with what theoretical we should get. That's how you actually get the percent yield. So this is a very, very long problem, but you could also get percent yield problems multiple different ways. The other way that you can get it is if you just give you moles, a moles of a product and a moles of a reactant. So in this case, what we're going to be doing again is we're just going to work with from moles of oxygen to moles of water. And again, we will consider this moles of water to be non-existent. And 10 moles, it's a mole-to-mole problem, requires the use of the balance equation once, right? And we if we use 10 moles of oxygen, according to the theoretical yield, we should get 20 moles of water. However, we only have 12 moles of water. So if we do the same math, actually theoretical yield, this process gives us 60% yield in this case. Notice that the only difference between this problem and the previous problem is instead of grams of water, I just gave you moles of water. Instead of grams of hydrogen, I just give you moles of oxygen, which is a reactant in this case. So please try to hopefully you can wrap your minds around this quick and very brief video about percent yields.